Welcome everyone. Thank you for joining today's webinar, How to Collect and Query IoT Data with MQTT and SQL. Before we get started, a little bit of housekeeping items for everyone. To the right of the slides, you should see a resources box. We have a copy of the presentation as a PDF that you can download, as well as a handful of links for more information on FairCom EDGE and MQTT. Please do use the Q&A box to ask questions throughout. We'll make sure to save time at the end to get to as many of those as we can. And finally, when the webinar is over, a very brief survey will pop up. 3 questions. Just rate us on our presentation, the content, the experience, and let us know, anything that we can do to provide a better webinar in the future. Anything we did wrong, anything we missed, we're open to all kinds of feedback. But with that said, I think we can go ahead and get started. My name is Shane Johnson. I'm running marketing here at FairCom. Prior to this, I ran product marketing at MariaDB. Prior to that, product marketing at Couchbase. And way back, I was a Java developer and architect at Red Hat and a few other places. Suffice to say, I've been around databases for quite a while. I'm going to cover a majority of the material here today, but we're also lucky to have Mike Bowers here with us. And I could go on and on about how great Mike is, but maybe I'll turn it over to you real quick to say hi to everyone.
Hello, I'm Mike Bowers. I'm the Chief Architect at FairCom, and I'm here to support and help Shane answer any questions. And Shane's done a great job putting this webinar together. So I designed the product, and I'm helping. I have a team that QAs it, and so I'm very interested in all your feedback so we can improve the product and make it better for you. So with that, I'll turn it back over to Shane.
Thanks, Mike. And you guys can consider that the gauntlet being thrown, so feel free to ask the hardest, toughest questions. That's why we have Mike here. All right, a little bit about the agenda. I'm going to talk about MQTT for a few minutes, and we'll certainly kind of get into some concepts, a little bit around the features, but this isn't necessarily a deep dive into MQTT. But certainly if you want more of that in the future, let us know in that survey. Then we'll spend a little bit more time to talk about FairCom EDGE, give you a little bit of a product overview, kind of go through some solutions, ways that it can be used and deployed, how MQTT fits in there. Then we'll spend a little while on persistent topics, and this is really where the magic is. And you'll see this when we start to talk about the product overview and the architecture. And we'll conclude with a live demo, knock on wood. MQTT, I thought I'd start with a little bit of a personal story here about everything being connected. And this is kind of the Johnson family home over the past, say, decade, if you will. Early on, it's the usual, right? Laptops, computers, printer, phones, nothing out of the ordinary. Then all of a sudden, it's my home theater's coming to life, right? Xbox One is connected, even the receiver is connected, and then now all of our TVs are connected as well. Then my wife wants an Apple iWatch. It's connected. Then I kind of had an issue. I'm in California, and it's really hot here in the summer, and I've been given some advice from a colleague that he had this connected irrigation system. So I could understand what the temperature is, when it's expected to rain. So of course I went and got one of those guys and put it in. Then I had an obsession, I'd say about 2 years ago, around lighting. I kind of started with these whiz lights, kind of Wi-Fi lights that I can control with my phone. And then I wanted TV lighting, these really cool strips that go behind the TV and the corner of the walls. And so that was Philips Hue, the Philips Hue bridge got put in there. Then I got on the whole Google Nest kick, right? Locks, the video camera doorbell, thermostats, and then these kind of hubs, one in the kitchen, one in my office. Then my wife wanted a Peloton bike. I don't know about you guys, but they're all the rage where we are. And I follow suit with a treadmill that had iFit on it. And these are both connected to the internet as well. But even that's we're just still getting going, right? I've been looking at a Tempo, which is kind of a smart home gym. I realized, at Best Buy the other day, all these appliances are now connected. You can see what's inside your fridge from your phone when you're traveling. You can, preheat your oven when you're on your way home from work. I even found a toilet that was connected to the internet, had lighting and various other capabilities associated with it. Then there's the potential for electric cars. I started looking at grills. Now these grills are connected, right? You can get out your phone and set the temperature and monitor all these other aspects of it. Even garage door openers, right? I had some issues with my garage the other day, and I thought I might have to get a new one. They're connected, and they have cameras and sensors. And kind of the short of this is I have a mesh network at home, and I opened up the app for it, and I want to say there was upwards of 50 or 60 connected devices. My mind was blown. I just hadn't realized it was happening. I think I just assumed that my laptop and my phone, etc. But then I realized there's literally dozens of devices in my home that are connected to the internet. It's hard to imagine things that won't be. And then I just started thinking, even what I'm experiencing when I'm out and about. Kind of way back, actually, I remember counting shopping carts at a store that had RFID tags and sensors on them. And if you took them too far away from the store, the wheels locked, right? And you kind of had to make your way back. When I moved to San Jose, the first time we went to a parking garage, it was really fascinating because there's a kind of a dashboard at the entrance that tells you how many spots are open on each floor. And sure enough, as I make my way into the garage and I'm driving around, above each spot there's a little light that's either green or red. Green if it's open, red if it's occupied. So I thought that was really interesting. And then we did some more traveling, and we came across parking meters where you have to install an app on your phone, then you tell it what spot you're in, and you do your payment through a credit card. Or even most recently, and I was chatting about Mike with this when I got back from vacation, we went to this place called Great Wolf Lodge, and it's kind of like a resort with an indoor water park and restaurants and various activities. And when you check in, we're all given these wristbands, and then we use those wristbands to pay for our activities or pay for our meals, which is super convenient. I didn't have to bring my credit card and driver's license around with me everywhere I went. Or in the case of my children, we go to Chuck E. Cheese, and when I was a kid, that meant putting cash in a machine and getting out these tokens. You can go play games in, and then they spit out the tickets that you take to the counter later. All that's gone. They too have these RFID wristbands when they come in, and they just wave their wrist in front of the games, and they play, and all the tickets are associated with their online account, and then they get their gifts when they're done. So I just thought it was, if I took a moment about it, everything's connected. All kinds of devices. And then of course there's the smart term, which I only listed smart city, smart farm, and smart factory, but you could probably attach any noun after that word to describe how things are changing. And certainly it's happening in every industry. I think MQTT itself can kind of trace its roots back to oil and gas in particular, but certainly a lot in transportation, shipping and logistics, telecommunications, and I tend to get really fascinated by all things retail, but even retail, right? They're putting sensors in stores to understand the flow of traffic, where people are going with their carts, where they're pausing, where they're stopping. So everything's changing. It's everything we interact with is ultimately connected to the internet now. And when I think about that a little bit more, for me, technology is all about the data, especially in this particular case. And what we really need to unlock is the ability for all these various devices to send and receive data. Or if we're talking in terms of MQTT, that means being able to publish the data, right? So when a device is generating data, it needs to publish it somewhere. Or you have some devices that will take action upon receiving data. So they need to subscribe to it in order to get it. And when I think about kind of the whys, from a consumer point of view, I think it has a lot to do with insight and automation. It's nice when we think about Google Nest Thermostat to go back and look at a dashboard of the temperature of my house. Compare that with my electric bill when we're there, when we're not, or automation. Part of the reason I got that Google Nest Hub is I'm walking around the house and I can say, hey, Google, lock the doors. And she does it, right? It's amazing. Or, hey, Google, it's TV time. So it turns on the TV and the TV lights and the receiver and the Xbox, all that good stuff. Or from a business point of view, probably lots of reasons, but I think AI and ML is going to be at the heart of a lot of those. If they can get all this data, then they can kind of start to improve operational efficiency or productivity, especially if I'm thinking in terms of, the industrial internet or industrial IoT. It could be improving the customer experience, right? I mean, part of the reason that we get a Google Nest thermostat is we assume, Google's going to be analyzing that data and then can kind of start to start, kind of changing my temperature for me, right? I don't have to turn it down at night or turn it down when I'm away, or to turn it up when it gets super hot outside. Google's aware of all those inputs and taking action on my behalf. And of course, all those things are really about delivering more value, maybe in particular in B2C, to me as the consumer. The smarter Google is with managing my Nest thermostat, I'm going to save money, I'm going to be comfortable, and it's not tedious. I don't have to worry about it, right? They're delivering more value to me. And this is all happening because of access to data that, if we look back 10, 15, 20 years ago, would have been stuck in a black box. But as we start to talk about IoT, we have some limitations around the devices. They don't have a lot of hardware, right? I understand Intel has, I don't even know what it is today, 40, 50, 60 core processors. I can promise you there's not a 60 core processor sitting inside my Google Nest lock. Unreliable connections, right? Especially when you're thinking maybe oil and gas or remote places, low bandwidth, high latency. What's the impact of that? Yet at the same time, bi-directional communication. So I think about maybe the lights in my house, for example. It's probably useful for Philips or to know when those lights are on, when those lights are off, how much energy they're consuming. But it's also bi-directional because I can tell it, hey, turn my lights off, dim the lights, change the color. So it needs to be able to receive messages to take action as well. Guaranteed delivery, right? There are certain environments where that data can't be lost. Yes, sensors generate a lot of data, but there might be critical, readings, alerts, notifications, alarms. If that message is sent, it has to be guaranteed to be received. And certainly security is going to be top of mind, right? When I think about my home and all those dozens of devices, that's certainly, personal size sensitive data that I don't necessarily want to be sharing with the world when I leave my home or if I left my, doors unlocked. So I expect that data to be secure. This is where we get to MQTT. It's a very lightweight protocol. So there's lots of messaging protocols out there. But, when we kind of think back about those constrained devices, we want one that's lightweight, right? Small footprint, low resource utilization. We want something simple, right? I mean, these devices, they just want to send and receive data, right? We don't want to add a lot of complexity into this environment. It is standardized, which is why you're going to start to see MQTT everywhere. And it follows a publish-subscribe approach, right? So Kylan's publish data somewhere, happens to be a broker, and then those same clients or other clients can then subscribe to that data through that broker. So in a sense, you have clients that are sending and receiving data, and you have a broker that's kind of hosting that data, if you will. There's other capabilities and features in there, but it's a little bit like a middleman in that diagram below, right? You have your sensor, which is kind of publishing the temperature, and then you have clients, right? It could be your phone, it could be a climate control system that's receiving that data, and that MQTT broker sits in the middle. It's brokering those messages. Some high-level features, and we don't have time to go into all the details here, But the broker, one of its responsibilities is message filtering. It might be have hundreds, thousands, millions of clients publishing and subscribing to data, but they're not necessarily all subscribing to the same data, right? So it needs to be able to say that if this client just wants this particular set of messages, that's all the client is going to receive. Quality service, touches on the guaranteed delivery that I mentioned a little bit earlier. There's different levels from far from guaranteed, at most, all the way to guaranteed, exactly once. Persistent sessions. So understanding that, clients may be, for lack of a better word, ungracefully disconnected. Right? It could be powered off. It could be a network error. How can we handle it when they come back on and we just want them to resume? Maybe we don't want them to miss any messages that were published while they were offline or disconnected. Those are all in MQTT 3.1.1. There's a few more there. And then certainly more features came recently with MQTT 5. I think some of those notable ones might be user attributes, ability to insert kind of name value pairs in our messages to provide more metadata, and shared subscriptions as well. Shared subscriptions, I think that the difference is that typically with MQTT, every client who subscribes to a topic receives the same messages versus a shared subscription is an environment where all those clients to a topic, they're kind of, think of them as round robin, right? So a message is received by only one of those clients. So it kind of spreads out a little bit. There's some other nice ones in there too. A few notes on tools. MQTT ecosystem is growing. And I provided a link there for more. But here are some kind of standouts for me as far as clients. You can see that just about every language has a client available for it. There's a number of GUIs out there. We'll talk about ours here at the end with the demo with MQTT Explorer. But you can see there's some for Android phones, there's plugins for the Chrome browser, and there's some CLIs too. These are some of the more actively maintained tools, but like I said, you can go to that link and find dozens more across these categories. So very easy to get started with MQTT. So that gets us to the product overview. I want to talk a little bit about FairCom EDGE. And these first few slides are kind of the architecture. I'll show you how we piece this together. It starts with FairCom DB, right? That's our database, lightweight, high performance, extremely optimized, portable, can run anywhere. Has SQL, as you would expect, also has a REST API as well for HTTP access. And then on top of that, we have a set of what we refer as Edge plugins. And these four in particular are essentially protocols. So it allows FairCom DB to capture data via OPC UA or Siemens F7. Think of these as popular protocols in the industrial space, right? Machines and equipment. These things tend to speak these protocols. So this is a way for us to capture that data in FairCom DB. MQTT, which we've talked about here, we'll certainly talk about a little bit more, and even the ability to capture that data and then push it to ThingWorx in the cloud. So regardless of whether it's come through OPC UA or MQTT, we can take those messages and we can push them into ThingWorx. And there's a few additional plugins. We're not going to cover these today. We'll probably cover them in a follow-up webinar. That are around, automatically timestamping messages, performing continuous aggregation on those messages, and even purging the data so that you can kind of run out of disk space, for example. What that means is, on one hand, we can capture or collect data from various machines, sensors, and connected devices, whether that's some kind of fabricator or temperature sensor, or as I said earlier, my thermostat or doorbell. We can capture all that data very easily. It also means, because we're built on top of FairCom DB, Then we can do things like build custom dashboards through that REST protocol. We can even get access to all this data building our own separate applications. Maybe there's an entirely different web application being developed. And of course, through SQL, JDBC, ODBC, you can even access data through traditional BI and reporting tools. So it's kind of end-to-end here. We have all these different ways to ingest this machine data, and then certainly kind of new and existing ways to access it kind of outside the scope of IoT. And finally, we have web applications that come as part of FairCom EDGE. And we'll look at both of these in the demo, MQTT Explorer as well as SQL Explorer. So this is, it's a complete platform, and we're going to talk a lot about the MQTT capabilities. But the magic here is all of these things combined. It's that, yes, we have an MQTT broker, right? We can publish and subscribe to data, but we also persist it, map it to tables, make it available through SQL and through REST, have web UIs through MQTT Explorer and SQL Explorer. That is much, much more than a traditional MQTT broker can provide. There's a number of deployment options too. And some of this really has to do with FairCom DB being as lightweight as it is. You can prune it to as little as 20, 30 megs, right? You don't need much by way of memory or processor to deploy it. So all the way to the left, you can actually just deploy it on those devices. And there's some benefits of that. One is you're not really reliant on network connectivity anymore. You're continuously publishing data to yourself, in a sense. You don't also have to worry about latency for that matter, either. Or you can deploy it on gateways. So these are typically appliances that you would deploy in a retail store or on the factory floor, in a gym, wherever it might be. So kind of right at the edge, but not on the device per se, or even in the cloud. Right? You can certainly run it in the cloud. There's lots of instances, including very big instances, and this could be a nice way to aggregate data across multiple locations. So you might have say hundreds of devices at a location. That data is aggregated at a gateway, and then you might have gateways in different locations across the country, across the world, and then those can be aggregated further in the cloud. So it's kind of up to you where you want to run FairCom EDGE, or where you want that MQTT broker to reside. I think the sweet spot is going to be that gateway. So as I mentioned before, you can put it on the device, right? So the device is essentially publishing messages to itself. And then, of course, FairCom EDGE could be deployed as a gateway, and then it can actually subscribe to that device. But it works really well, on these gateways. It's a nice way to do some on-premises, aggregation, lightweight analytics, messaging handling, and then it can certainly push that data to the cloud, whether it's FairCom EDGE in the cloud or it's Azure IoT Hub, MQTT broker of your choice in the cloud. So Edge Solutions, I think this is a little bit fun because we start to kind of be imaginative in what we can do. So one of them is we kind of started hinted at is protocol conversion, right? So I can capture OPC UA data for a bunch of factory machines, for example, and then I can publish those to Azure IoT Hub, where we want to do something in the cloud. I could get MQTT data from a whole bunch of devices. Maybe it's home security systems or alarms or exercise equipment. Capture all of that data and then maybe publish it to ThingWorx if we want to. So we can get data in different protocols, and then we can move that data elsewhere in a different protocol. Some examples, like I said, this one might be a little bit more industrial IoT focused. Think of factory. We have various machines and sensors. We get that data through those industry standard protocols, and then have it pushed to Azure IoT Hub through MQTT. And then this is kind of what I was saying with multiple location points. If you have multiple factories, you might deploy FairCom EDGE at each one of those factories, right? Maybe some factory seeds are all on OPC UA, others are still all on Siemens S7, some are a mix of the both. It doesn't make a difference to FairCom EDGE. right? We can aggregate that data at each factory, and then again, for example, have that data pulled into Azure IoT Hub, kind of global aggregation in the cloud. Another common example is MQTT to ThingWorx. So it's not very easy to get that data into ThingWorx, and FairCom makes it really, really easy with FairCom EDGE. So this could also, again, it could be a factory floor, it could be a retail store, right? It could be a gym, it could be an amusement park. We're gathering all this data through MQTT right there at the edge, and then we can push it to ThingWorx for you, where you can work with it there. Again, similar concept if we wanted multiple locations, right? Multiple amusement park locations. It could be, hotels, right? And each hotel has, a FairCom EDGE deployment that's gathering MQTT data on, it could be the temperature of each hotel room, whether the door is locked or unlocked. And then, of course, all that data pushed into ThingWorx. Or just as a straightforward MQTT broker. Right? If you're not concerned about these other protocols, we could just focus exclusively on MQTT. Right? Some devices are publishing data, some might be subscribing to it, some might be publishing and subscribing. And I think we might touch on this later. But at the same time, FairCom EDGE can also subscribe to data from other MQTT brokers. Right? So you have an existing MQTT broker somewhere. FairCom EDGE can essentially act as a client, subscribe to that data. And conversely, other brokers, maybe you have a cloud MQTT broker, can subscribe to FairCom EDGE, right, to subscribe to its data. And then we get to persistent topics. We'll talk about this for a little bit, and then we'll jump into our demo. But as I alluded to when we were talking about the architecture, this is where things get really interesting. And I kind of put MQTT meet, SQL here. Is traditionally MQTT brokers store messages in memory, right? There's kind of a fixed limit there. You'll run out of memory, you're going to have to start purging messages. If they're restarted, you're obviously going to lose, whatever is in memory. Sometimes there's other, persistence options that may or may not be supported depending on the broker you're looking at. But FairCom EDGE, we think in terms of persistent topics. Right? And these are stored in tables, they're stored on disk. And there's a great deal of flexibility here. And I'll show you this with the demo, is you can kind of store them in user-defined tables, right? You say, here's my table name, here's my column names. You can also kind of map them to existing tables, if that makes sense. And we do a lot by way of JSON. So we kind of assume that the payload is a JSON document. And when it's a JSON document, we can actually go a little bit farther. Kind of start to parse those documents, extract those properties, and then put them in different columns within our table. But before I get a little bit farther into that, we're looking at persistent topics and how we manage them. FairCom EDGE, after it's installed, it actually has the C tree administration topic. That's kind of what it sounds like, right? It's an administration topic. Publish messages to that topic to do things like create persistent topics or pause them or delete them. And what you see here is just a very simple example. So that operation property, create persistent topic. Or if we wanted to pause it, it would be pause, persistent topic. Then there's the persistent topic property. That's simply your topic name. So kind of the example I have here over the next few slides is I was thinking about a bar and bottle shop. There's kind of two of them where I live that I'd like to visit. And of course, being a bottle shop, that means they have lots of coolers, right? Cans and bottles of beer. And I was kind of thinking about, how IoT would apply to this shop. And I thought one of the things they might want to do is kind of monitor the temperature of the cooler. So I have a topic, a district, which could have multiple stores, /store, and then a store could have multiple coolers, /cooler, and then a status, right? This is where my messages are going to be published. And I have two simple properties here. One's the cooler ID, and one's the temperature. And you can see there's a little bit of mapping. So in the JSON document, it's called cooler ID. But in my table, I just want it to be called ID. And while it's called temperature in the JSON document, I just want my column name to be temp. Right? And I use small tiny ints here for the data. So we're going to kind of parse these JSON documents, as I said, even if they have arrays and nested objects and deeply nested objects, we can parse all that. And we can also kind of map, JSON types into, standard database types, if you will. And this is kind of defined when we create our topic, either through the JSON document, which I just showed you, and we'll see some more of those, or visually through the MQTT Explorer. And I'm going to show that too here in just a minute. There's a lot of optional properties. We don't have time to go into all of these, but I think some interesting ones are around the JSON. So if there's, you could store binary data in JSON documents. Even though there's not an official time or date type, you can store that in JSON documents, right? They're just strings, but they have a certain format, so we can understand that. External broker is pretty interesting. I kind of hinted at that earlier, where we might be deployed as an MQTT broker, but if you have others, we can subscribe to them and pull that data in and then persist it, just like one of our own persistent topics. So I wanted to return to the field mapping, because you probably saw there was a property in there at the end. And I'm going to kind of invert it and start first around the messages, right, that our devices are generating. So this particular shop, they have a cooler, they have two coolers, and they're kind of, they're sending messages of what's our current temperature and whether the door is open or not. So there's cooler ID of 1, 50 degrees, the door is closed. Cooler 2, it's at 45 degrees, the door is open. Then there's another reading from cooler 1. So fairly simple messages with some sensor readings. How would I want to map that to the database? It looks like this. So here's kind of that create topic message we just looked at it. But more notably here is that fourth property, map of properties to fields. And so we're going to say property path cooler ID, right? It's going to match in the message. Field name is what I want it to be called within the database. I could also have called it cooler ID. I just change it up here. Temperature, temp, and then door open. And I just called that open as my column name. So if I knew that this is what my messages were going to look like, this is how I would create my persistent topic, and this is how those messages would look like under the covers. Right? I inserted those 3 messages. Behind the scenes, those 3 messages were inserted as rows in this TBL cooler status table. But we can go a little bit farther. So I started thinking, all right, well, they often have pretty big coolers, and there's multiple doors on those coolers. So maybe once a second, once a minute, we're going to send a message that tells us what our temperature is and what the state of each of the doors is. Right? Maybe this is a 3-door cooler, right? And any one of those doors could be open or closed at any given time. And I think this is interesting because if I wanted to apply this, I might want to start looking at, let's look at our purchases, see what kind of beers people buy. Right? Are there certain types or, certain brands that people tend to buy together? And then I might compare that against the sensor data to see when my doors are open and closed, because I might be able to find an optimization where maybe related beers should be behind the same door. So that instead of a person opening all 3 doors and letting that air out, the temperature dropping, they just open one door, get the beers they want, close the door. So there's interesting applications of this IoT data, but this is a little bit trickier because we have an array. So how would we map that? Well, it looks a bit like this. And I kind of trimmed this to just cut out the map of properties to fields. You still see the cooler ID as we did before, temperature as we did before, but we kind of change it around. So now we have a property path called doors, and we say there's a child table. It's called TBL door status. And then we map its properties. So there's door ID is going to go to this ID column. Door open is going to go to this open column. now it looks a little bit like this. So we have this message that came in, right, at 9 a.m. Is 50 degrees. And then another table we see that for each of its 3 doors, here's their state, whether they were open or closed. Now, automatically, FairCom EDGE is adding that primary key and timestamp in that first table, and it's automatically adding that foreign key. Well, I see my little typo there. I'll have to fix that. And position columns in the child table. So in the first table, ID and temp, that had come from cooler ID and temperature. And in the second table, ID and open had come from, door ID and door open, right? So we kind of map these JSON documents into structured relational tables under the covers. And then finally, we also have store and forward. So it's kind of a newer feature. It's a little bit similar to persistent sessions in MQTT, but also a little bit different. And for us, it means that existing clients, when they reconnect, simply resume where they left off. So if one of our coolers lost power, or maybe not lost power, but maybe one of our coolers was publishing, a whole bunch of messages, and maybe there was some kind of control system, that they would respond to that, right? Raise the temperature, lower the temperature. Well, the control system, let's say it got disconnected and it lost power. The cooler's still setting those readings around the temperature, and they're kind of queuing up, if you will, in FairCom EDGE. Now, when that, kind of cooler controller comes back online and reconnects, it will catch up, right? So wherever it left off, it's going to get all the messages it missed while it was disconnected or offline. And then the other thing, it's kind of a little bit different, is new clients can choose to catch up from the oldest stored message as opposed to just the next message, right? So typically when an MQTT client subscribes to a topic, it starts getting, new messages, right? The next message, and so on and so on. It has no visibility into all the messages that were created before it subscribed. So with store and forward, that's a little bit different. Now it has the option to say, hey, I want to catch up from the oldest message you have. And there's a few properties in here. These are, again, around the create persistence topic message that we've been looking at. But those 4 bold ones are for store and forward. Certainly one is to turn it on. The other one is kind of the delivery rate. So you can think, if we backed up thousands of messages, how do we want to throttle that? Right? It should be about 100 messages a second. Should be 1,000 messages per second. New subscriber delivery mode. That's what I was telling you kind of about before. That stored messages mode says, hey, start going, as far back as we can, as opposed to just start with the next one. And then max stored messages, right? We might want to store an infinite number of messages, but maybe at all times we want the last 1,000, last 10,000, and so on. So that brings us to the demo part. I was looking for some images last night to put here, and I really love these 3 because they remind me of myself. If I were you, I'd probably be very anxious to get to the demo part, right? That's what I really want to see. I also happen to be the type of presenter that is totally fine to jump in and do that demo. But I've also been the developer, and I'm sure Mike, on behalf of his engineers, is praying right now as well that all works and goes well. So I'm going to share my screen. So I'm going to share my screen. So hopefully everyone is seeing my screen right now. So this is a browser that I have up and running, and we're looking at MQTT Explorer. So localhost 8443 running on my machine. I'm going to pause for just a second, though, in case something on the other side, if you're not seeing the screen or it's blank or something unusual is happening, feel free to let me know. I'll try to monitor the Q&A here for a second to see if something happening. Otherwise, I'm going to assume that the screen share is working okay for everyone. Okay, I'm going to go ahead and continue things. I think we're okay. So we have logged in here. I'm going to come to this Topics tab. And we're going to create a new topic. And I think I did district/store/cooler/status. And I'm kind of going to override this a little bit and say I want it to be TBL cooler status. And then we need to add some properties. So if I'm not mistaken, it's cooler ID. We'll just call it ID in the table. I'm just going to put it in a small int here. We'll save that. And then we'll add another one. We'll call this temperature. But in the database, the column name will be temp. And I'll just do a tiny int here. Hopefully it never gets over 127 degrees in my beer cooler. And then we'll add another one. It's called door open. Open in the database. And this could just be a bit, right? It's Boolean, true or false, right? On or off. So we have 3 properties in the messages that are going to be generated by our cooler here. And then I'm not going to change any of the defaults, but you can see that a lot of these things are already set for you. I'm going to finish. So it shows me a preview of the JSON we had. And of course, we have a new persistent topic created, which is pretty neat. So now I can go to subscribe. And I'm going to click on this new topic that we just created. And essentially this MQTT Explorer, I'm telling this as an application, this web application, to subscribe to this topic that's in FairCom EDGE. And now we can go to publish. And I saved a few examples here. Make it a little bit easier for me. Say, let's publish to the status. And we'll publish some messages. This is cooler 1. Say, cooler 2 and 5 degrees. The door is open. Publish that message. We'll go back to cooler 1. And we'll say that the temperature, maybe it's gone up to 60 degrees. And the door is open right now. Then we can go to that monitor tab here, and we can actually see these messages that I've been publishing. So this is all through MQTT. So this publish, this browser, this web application has its own embedded MQTT client in it. So every time I publish messages through here, do one more. And then the monitor is kind of going through and kind of subscribing and showing me the messages that I'm being created. So pretty self-explanatory. And then we can go to this data tab right here. I'll do a refresh, and we see our table cooler status table. And we see some records in this table. But I'm going to mix it up a little bit here, and I'm going to delete this topic. And it's going to give me a warning, because once I do delete this topic, it's going to delete the underlying table, and we're going to lose the messages and the data. Well, that's okay for our purposes, so we're going to go ahead and delete that. And what I have in here is the kind of the slightly more complicated example I showed you, where we have nested data. And this is the kind of the JSON definition. So we're going to mix it up. You can use this persistence topic UI to go ahead and create topics just as I did. But on this Publish tab, instead of our cooler topic, we can go to that administration topic. And I can put this JSON document in here, which is going to say, hey, create me a new persistence topic. We have a cooler ID, we have a temperature ID, but we also have this doors array. And I want those values to be in a separate table. I'm going to go ahead and publish that message. And we'll come back to topics here. Do a little refresh. Sometimes it takes a minute to show up. So here's my operation. Oops, I have one typo in here. Sorry about that. Keep forgetting this doesn't need to be in here. Let's try that one more time. Publish our message to C-Tree administration. It's published. This is my new message that I just published a minute ago. And there's my topic. It's been created. And I also have another example of a message for that topic. We can do a few of these here. Go back to our Publish tab. I'm going to change this to status. So this is a little bit different now, right? We have the cooler ID, we have the temperature, I have this doors array, I have 3 doors. And I'm trying to kind of keep track of whether they're open or closed. So I'm going to go ahead and publish that message. And then if we go back to data, do a little refresh, we see our 2 tables. So here's that message. The cooler is 50 degrees. And then there's this child table. You see we have our 3 doors. 2 of them are closed and 1 of them is open. But I'm going to publish a few more messages here. So maybe the temperature went up to 55 degrees because another door is open. Then maybe we'll do another message where now it's gone up to, say, 60 degrees because all 3 doors are open. And if we go in here, take a second for all that to check my monitoring tab here. So we have our messages coming. They're being persisted. The other nice thing I mentioned before is the SQL part. So I'm going to kind of refresh my connection here. And if I go in admin and I go in tables, you'll see our 2 tables. Here's cooler status as well as our door status. So at a high level, with just MQTT and JSON, right? Our cooler's publishing MQTT messages to FairCom EDGE. Those messages are JSON documents, and they contain information about the temperature and whether various doors are open and closed. But when we think about the slides I was showing much earlier, I did say that in addition to collecting data from various devices and machines, you can also access it through SQL in BI reporting tools or HTTP and REST. In this example here, it's a little bit of both because we have our SQL Explorer, which is a web app. So it's kind of using the HTTP APIs under the covers, but those are carrying SQL statements that we can send over. So we might start to do interesting things like select a ID as cooler, maybe average temp as temp from TBL cooler status, and group by ID. So the average temperature is 55 degrees. So to me, it's pretty interesting because the data isn't sitting in a black box per se, where these messages they're somewhere and I can subscribe or publish to them, but because they're persisted, I can interact with those messages directly as if they were data inserted through SQL or through a traditional application. So I think that's pretty interesting. And that kind of brings us to an end of our demo here. So I will stop sharing. hopefully everyone was able to see all that stuff okay and just fine. And that brings us to the end of our presentation as well. I did put some links on here. It is really easy to get started. So that link will take you to the downloads for FairCom EDGE. I happen to be using Windows today. There's both an installer and a zip. I would just grab the zip. Then you can unzip it. Double click on that faircom.exe, which is in the server directory. Simply click that link to open up MQTT Explorer, which I was just showing you a few minutes ago. And then you can kind of go to the documentation and kind of look a little bit deeper into things I showed today. But really, it's every bit as easy as I just showed you, right? Unzip, double click, open a link in a browser. You can start creating topics, publishing messages, monitoring messages. You can even pivot over into SQL Explorer, start doing more sophisticated SQL than I did with my simple demo here. But with that said, thank you for attending today. Hope you got something out of it. And like I said before, if you can, feel free to fill out that survey real quick. It's always nice to know, what we're doing well and what we can do better next time. And I think Mike's been on it with some of these questions in the background. But we have a few minutes here, so if you have any questions around FairCom, FairCom EDGE, MQTT, I'm happy to take those questions.
So Shane, we could read some of the questions that they've already submitted.
That'd be great.
So Michael submitted a question on purging data, and he was asking about, is that garbage collection? And shortly, the simple answer I would say is we are written in C and C++, so we don't have garbage collection issues. It's very predictable, consistent, fast performance for all of our built-in components. We do have a data purge function because we are collecting data from all sources, no matter whether you come in through MQTT or OPC UA or REST or SQL. And that data, we have the ability to automatically purge data at a configured rate. So if you want to say purge data over a month old or a year old or a day old or whatever you want to keep your data small on disk, we can do that automatically so the data doesn't grow out of control, or not. We can keep the data forever if you have lots of storage. So I think that's the purge feature that he's referring to. Another question is, what IoT operating systems are best suited for FairCom DB at the edge? That's a really great question. It depends on what you're trying to do. FairCom EDGE can be used for devices, gateways, servers, all kinds of hardware. We run from very small to very large. And so if you're going to be used for a gateway, then Linux or Windows is very typical for an edge gateway, which is the use case where you're going to set up an MQTT broker in a factory, and you want to do more than just broker data, though. You want to transform data, and you want to gather data from lots of sources like OPC UA or REST and MQTT and other protocols. We support plugins, so you can support any protocol. And then we can deliver that data to any other protocol. Come in through MQTT, go out through OPC UA, vice versa. Come in through REST, go out through OPC UA. So we have this ability to send data in from one protocol to another. That's really suited for a gateway, and gateways are typically running Linux in factories, but they can run Windows just fine, and we do both. But if you're running on a device, you probably want a real-time operating system, and there's a whole bunch out there, like Contiki and FreeRTOS and a whole bunch of those. FairCom EDGE is written in C and C++ code, and it's designed to be portable. So we've ported FairCom, the core engine of FairCom EDGE, which is FairCom DB, to over 80 operating systems over the last 40 years. We've been in business for 40 years, so we've supported about every OS out there for different use cases, and we can port FairCom EDGE to any operating system that you need. So just let us know what you need to do, and we'll look at your use case, and we can work with you on that. So we support pretty much any operating system you want for your use case. Also, Android. Android is a great platform for a lot of edge use cases because Android runs in a lot of devices. My TV is an Android TV. And so FairCom EDGE can actually run on my Android TV, strangely enough. It can run on an Android phone. It can run on an Android tablet. It can run on those augmented reality glasses with an Android OS. A lot of stuff's happening in that space with Android. So just imagine walking into a store with your Android phone and having on your phone an MQTT broker, a REST API, and a database, and having the ability, if you allowed it, of course, you have to be authorized, you could interact with the store, with a factory, with, if you're a doctor, a hospital room, with your mobile device. Your mobile device can have all this capability to be connected through all these protocols instantly on Android. We're also working in the future on iOS devices as well, coming in the future. So your mobile devices are a big edge use case. So it really depends on your use case to whether you want us on a little device operating system, or you want us on a gateway, or you want us on a mobile operating system. So that's what we're working on. Let's see. There was, it says, what would be the advantage and use case for FairCom DB deployed at the edge? Why would you want a database on the edge? Well, FairCom Edge is more than a database. It's really, there's a lot of reasons you want a database on the edge. You want the ability to store data, query data, remotely access your data from anywhere, if you're authorized, of course. We have a full security and authorization. Because it's a little scary to have a database sitting out there that you could go into remotely from any point over the internet. But of course, you have to be authorized, and it's very secure. So with the answer I gave when I typed it up was with a simple unzip of FairCom Edge. So that's all it takes. You just unzip it. You instantly have an MQTT broker with all of its capabilities, a REST API. You have SQL database, and it's also a NoSQL database as well, with a really cool navigational API. And then it's also got the connectors to a whole bunch of protocols like ThingWorx, NoPC UA, Siemens. We integrate with Siemens PLCs. And we have JSON RPC API to remote control all these features. So the key point is you unzip our FairCom Edge and you instantly have a fully integrated broker, database, connector, REST, and user interfaces like Shane was showing, SQL Explorer, and MQTT Explorer, all these browser-based user interfaces, and you can build your own because we have an app server built in, so you can add your own browser-based apps. So that gives you the ability, so the advantage of why would you want FairCom Edge? Well, because it gives you all those capabilities, all with a simple unzip, all integrated. It's not a hodgepodge of different products from different vendors, sort of half-baked. This is one unified set of tools that have been written and tested and integrated by FairCom. And so this is FairCom technology, fully integrated, ready to go out of the box. You just unzip it and go and have all these capabilities built in. And I don't know if there's any other questions. I think that's the 4 questions I saw.
Yes, well, and we're actually at the top of the hour here. So thank you, Mike, for joining us and helping us with Q&A. Thank you to everyone who attended. I hope this was informative for you, and thank you to the demo gods for looking kindly upon me today. Hopefully that was great for everyone as well. Like I said, if you can fill out the survey, let us know what we did well and what we didn't, and we'll see you next time for our next webinar. Have a great day. Bye, everyone.
Thanks, Shane.